Okay. Good afternoon, everyone. Welcome to Neediss series webinar. My name is Nachan. I am a sales engineer for Neediss. Today, the speaker is Mr. Terry Lam. He is a sales manager for Gasmet Technologies. He will present about Mercury monitoring. So I will pass to Mr. Terry for continue the presentation. Okay. Please let's start.
Yeah, so thanks for the introductions. So does anybody, can anybody see the screen right now? Hello, can you see my screen?
Yes.
Okay, so today I'm going to present our Gasmet Mercury monitoring system and also share some experience for the market. So I'm Terry Lam, the sales manager from the Gasmet Technologies Asia. Let me show this doc first. Yes, I'm from this company, Gasmet Technologies Asia. So before start my introductions, actually I prepared a few slides for introducing our Gasmet company. So there are some content I draft. So I will share some background information to you of use, and then I will talk about our systems and share some system parts, including the sample probe, analyzer, gas generator, and the cabinet for our Mercury system. And also talk about the software and what technology we use for detecting the Mercury gas compound. And last, I may share some applications and the competitions in this Mercury monitoring market for you. So at first, Gasmet Technologies is a Finnish company in Finland. We only manufacture high-quality gas analyzer with using FTIR technologies for typical gas monitoring, and also CVAF atomic fluorescent technology for mercury gas monitoring. And our application is not only limited to the industrial side, but also used in the safety side, like in the fire department and also in university for research purpose. Our company established since 1990, so we have more than 30 years experience in making gas analyzer and develop our strong market in the industrial monitoring. The first FTIR is manufactured by Gasmet in 2003. This is the first in situ FTIR in the world, and also the first truly portable ambient gas analyzer by using FTIR is also manufactured by our Gasmet in 2008. At the moment, we have about 58 distributors in the world, well, actually it's over 70 countries. And at the moment, we have sold more than 4,000 gas analyzers in the market. So in case you have any question, you can just stop me and then raise up your questions. So let me know. Otherwise, it is quite difficult to going back to the slide and then ask the question again. So Gasmet has about more than 100 employees in 5 offices. Our headquarters is in Finland, and also all the gas analyzer, all the system will be manufactured by our Finland headquarters. Then we have 4 subsidiaries. One is in Hong Kong, one in Canada, UK, and Germany. In Hong Kong, because we handle the business in the whole Asia Pacific regions, so we have another distributor in another Asia country as well. At the moment, we have about 38 distributors in APAC regions. We also have a service center set up in Hong Kong. So basically, we can do all kind of maintenance for our Gasmet analyzer. We keep all the spare parts inventory in Hong Kong as well, so we can deliver the spare parts directly from Hong Kong to Thailand. So normally 2 to 4 days you can get the spare parts for fixing your system. And also we have some demonstrations or able to arrange some seminar to our potential customer, so you can know more about Gasmet. You can understand more about Gasmet products before further considerations. And also we have our special tools for the calibration surface. So here is our product line with using FTIR technologies. So we have our CEMS system for the typical gas monitoring, which can be used to monitor organic and inorganic gas compound. And also we have a portable device which is full gas monitoring and also for ambient gas monitoring. The last category we have analyzer for the engine emission test. Most likely it is using for the research purpose or in automotive industry. Some of them is using FTIR technologies. With using FTIR, we can provide these 5 basic features. One is we are able to monitor up to 50 gases at the same time, and we don't have to use standard gas for calibrations, and able to identify the unknown gases. So this slide is only cover the FTIR, not for Mercury. For Mercury, it's in here. This is another system for the Mercury gas monitoring. We measure the total mercury from the stack, and this analyzer already certified the lowest range of 5 microgram per cubic meter in the world. I will talk more about this analyzer in the next few 10 minutes. Our Gasmet CEMS system in APAC, it can be used in different areas, like in power plant, incinerator plant, foam oxidizer, even cement plant. In the incineration market, we are quite strong in this market because they have to measure HCl, HF, and ammonia, so it is quite favorite to using FTIR. As for the mercury system, we call CMM. Our mercury system is quite strong in the coal-fired power plant, incineration plant, and the cement plant, because there are regulations in Europe for the coal-fired combustion plant. They have to install mercury system for continuous monitoring. And also for the incineration market, they have a regulation to support the mercury CEMS. And as for the cement industry, the regulation is reviewing. Maybe early of next year, the regulation will become up. But these 3 industries for the use of mercury is in Europe, not in Asia yet. But we foresee the mercury regulation is getting tough, and more Asia countries will follow the European standard.
So, sorry, how about the China regulation?
China, no. They have talked about the mercury monitoring for a very long time, over 10 years. But until 2 years ago, still in pending stage. They don't officially set up the regulation.
But they have any potential more than in Thailand for the power plant?
Yes, but it depends on the local regulations.
Oh, okay.
Yeah. Even in China they have regulations, but in Thailand if there's no regulations, so maybe as a consumer they will further think about the futures.
Okay.
Okay. So our Gasmet company policy is according to ISO standard, and all of our Gasmet analyzer, including the FTIR or the mercury analyzer, they are certified by TUV and also EMSA. So here are the certificate we obtained from TUV and also EMSA. EMSA is from British, TUV is from Germany. So now I'm going to share some facts and sources of mercury. Maybe you already know what is mercury, because mercury exists in our ambient more than 1 century. But I would like to share some facts to you. Mercury is the only metal in liquid phase at standard conditions, that means at our ambient conditions. Mercury is quite heavy, commonly known as a quicksilver. The density of the mercury is about 30 times of the liquid. So we can consider the same volume of liquid and the mercury. Mercury is much heavier than the liquid, than the water. During the mercury emissions from the industrial side or from the stack, normally they occur as a mixture of elemental mercury and oxidized mercury. They are extremely toxic. The 2 types of mercury substance have different characteristics. For the elemental mercury, it is water insoluble and highly volatile, vaporized in our atmosphere. As for the oxidized mercury, primary is mercury chloride. Mercury chloride is water soluble and easily be absorbed at cold surface. So the effect is more regionally because once the mercury chloride released into the atmosphere, it will be participate into the landfill or into the water because it will be soluble in water. So when we talk about the mercury, we would consider the total mercury, which is the summation of elemental mercury plus the mercury chloride. And the concentration of mercury from the stack is 1,000 or 100,000 times lower than the concentration of other gas. Or we can say the concentration is in microgram per cubic meters level or in ppb level. For other typical gases like SO2, they are talking about in ppm level, is 10,000 times lower. Mercury is existing in our daily life. For example, the hearing device, the calculators, thermometer, even for the battery or the camera. Mercury existing in these products, although it is invisible to our human being, but already manufacturers add into the product. As for the sources of the mercury, it could be classified as natural occurrence. Natural occurrence means mercury can be exist in as a mineral in form of cinnabar. Cinnabar was often used in the pigment as a pigment engraved into the jewelry. However, since mercury is confirmed as a toxic substance, it would not be used in this jewelry. Mercury can be existing in the mineral in rock and coal. That's why when we burn the coal, a lot of mercury will be released from the stack. Or the volcanic activities or forest fire or vaporized from the oceans that are considered as a natural occurrence. And the other 50% is from the human activities like mining, coal burning, oil burning, or waste burning. Mercury pollutants could be transported over 1,000 kilometers from the sources, so they have a very long range pollutions affecting us. And finally, the mercury could be entered into the food chain. Small doses of mercury can cause us very serious health effects to our human being or even cause any fatal effect. So that means mercury is not only harmful to the environment but also ecosystem. And that's why globally there are strong regulatory pressure to monitor the mercury emissions. From this picture, you can see the mercury cycle around us. About 50% amongst the 50% of the human activities, the largest source of human-made mercury is from the mining industry, then from the coal burning, waste incinerations, and also the cement productions. The last one or the least one is from the metal productions. From here, you can see all the industry. They have a chance to release the mercury into the atmosphere. The mercury could be vaporized into the atmosphere, and then through the wet depositions, they will going back to the landfill, to the river, through the rain and the snow. Besides the industrials, for the landfilling, the mercury will be vaporized into our atmosphere as well, and some of them will be goes to the deposit into the soil, and through the soil then go back to the river. This is very dangerous. Once the mercury is run off to the river or run off to the oceans, the bacteria will convert the mercury to methyl mercury. Methyl mercury is non-biodegradable. That means the methyl mercury will be accumulated in the fish, shellfish, lobster. So at the end, the bigger fish will have a very strong concentration of mercury accumulate in their body. So you can imagine at the end, when we eat the seafood with the shellfish, so the mercury will be deposited in our human body, and then damage our human health for long term. So from here you can see elemental mercury has a very long atmospheric lifetime, it could be transported globally from one country to other countries, and therefore it is not the single country issue, it's the global issues, because the mercury vapors, maybe from Thailand, it will be vaporized and then released to Malaysia or to other countries. As for the mercury chloride and the other mercury participant, they have a shorter lifetime because they are soluble in water. So the effect will be more locally and regionally. In US, according to the NIOSH the exposure limit they set for the mercury vapor is 50 microgram per cubic meters only, and they recommend the ceiling value is only 100 microgram per cubic meters, according to the OSHA. And this level should not be exceeded at any time. If more than that, let's say 10,000 microgram per cubic meters of mercury can cause fatal effects and very dangerous to the life. 10,000 microgram per cubic meters is talking about 10 ppm. So when you compare with the typical gases, the concentration is very low, already caused the fatal effect. So there are some health hazards for the mercury to our human being. The mercury can be absorbed by injections, by the skin contact, or by inhalation. And the damage effects could be to our internal organ, like kidneys, liver, and lungs. And the major effect is to damage to our neurological poisoning. And also there is some chronic effect that would accumulate poisoning to our human health and also impair the speech and visions. We call this effect is Minamata diseases. Minamata is a place in Japan. A very long time ago, there's an incident, quite famous incident happening in Minamata. A group of village got the methyl mercury poisoning. So after that, they set up a convention in the Minamata place as a since 2013, we realized the toxicity of the mercury. Even a small dose that would cause a very serious effect, and therefore they have set up a safe network to control the mercury emissions. So because mercury is so dangerous to our human being globally, so there's a need for the global effort to control the mercury emissions. USA is the first countries to finalize the mercury control. They set up a mercury air toxic standard since 2011. The next will be China. However, China, they talk about the mercury emissions very long time ago in their 5-year plan, but the regulation is still impending. They didn't officially set up the regulation for controlling the mercuries. The next one will be from India. They have released a mercury emission standard since 2015. And then the Minamata Conventions. This convention already ratified 3 years ago. And this convention is really affecting our APEC business or affecting our APEC market. I will talk more about the Minamata Conventions in next few slides. In Europe, they also released a draft document to control the mercury emissions from large combustion plants since 2017, and also for the waste incinerator plants since 2019. They have to compile the new emission standard of the mercury by 4 years' time. So this is the mass in USA in 2001. They have set up mercury emission limit value for coal burning, lignite burning, industrial boiler, cement plant, and cement plant. They have the plant or the industrial, they have to comply the regulation by 2016. From here you can see they do the continuous measurement for the coal burning. and also for the cement burning. And also they set the emission limit value to a very low level. It's talking about 1.4 microgram per cubic meters for coal burning. And for the cement plant, it's talking about 12 microgram per cubic meters. From here, you can see although they are talking about the continuous monitoring, in US standard, continuous can be considered as continuous data or continuous sampling, not continuous data. That's why continuous mercury monitoring in USA is still not popular because they can use a software chip instead of the continuous data. They follow different standards, PS12A and PS12B. As for the other industrial burner, they are still using the periodic measurement by solvent chip with the standard PS30B. So for the APEC, we concerned about the Minamata Conventions in 2017. It is a globally binding treaty in APEC to protect human beings and the environment from the damage of the mercury. This convention was organized more than 20 years ago. However, until 2 years ago, this convention already ratified and then effective since August 16, 2 years ago. All the countries who joined these conventions, they have to fully comply this protocol by 2020. In this protocol, they have a lot of highlights to control the mercury. For example, they have to ban the new mercury mine, phase out the existing one, control the use of mercury for production, for manufacturing, and then address the storage of mercuries. But what we concern is the monitoring from the stack. So they have another control measure on the air emissions and release to the land and water. We are talking about the CEMS for the coal-fired power plant, for the waste incineration plant, and for the cement industry. And that's why we need to have a same system for mercury monitoring in these three industries in APEC regions. Well, actually, not only APEC, it's global. And there's a table, a highlight the countries is mainly for the APEC regions. China, India, Indonesia, they all supporting this protocol. Even in Thailand, they also supporting this protocol since June 2017. So in Thailand, they should look at the mercury control in the very near futures. As for those countries who do not support this protocol, like Australia, Malaysia, Korea, Philippines, and Pakistan, but they have to comply this protocol because they have signed the initial agreement with them. So let's say this is the regulations from Indonesia. They just set up a new regulation for the mercury emissions control in 2019. And also they set up the emission limit value level to 30 microgram per cubic meters. They further expand the greenhouse gas monitoring from the gas-fired power plant. The gas parameters expand to CO2, N2O, and methane in 2 years' time. So that's why I said in Asia, different countries should update their regulation for mercury in the very near futures. So Indonesia is the first countries to review their regulation and then add the mercury into their regulations control. And this table.
Sorry, how do you know how many coal-fired power plants in Indonesia?
Well, more than 350. A lot. A lot of stack in Indonesia. One plant may have at least 4 to 5 stack.
Really? For the
yes.
power plant? They specify the capacity or not of the power?
In Indonesia, they don't care about the capacity. Only it is a coal-fired power plant. They have to install the CEMS for mercury. it is a little bit different because in Europe they only consider about the huge capacity with a capacity more than 300 megawatt. But in Indonesia, even you have a very small chimney, once you burn coal, you have to install a mercury analyzer. So these tables summarize the emission limit from USA and from Europe. In USA, the existing coal-fired power plant, the emission limit value is set to 1.4 microgram. In Europe, it's in the range of 1 to 4 microgram. For the new plant, it's only limited to 1 to 2 microgram per cubic meters. So that means in Europe, the countries can set different range or different emission limit value for their own countries, but the criteria is within this range and compile these brief documents. In Europe, they further regulate the mercury emissions from the waste incinerations. The range is from 5 to 20 microgram per cubic meters. So according to this EN 15267-3 standard, the system shall have a certified range they have well-defined a certification range for different applications. For example, the certified range for systems should be 2.5 times of the emission limit value for the large combustion plant. In other words, the range should be 1.5 times of the emission limit value for the waste incinerator. So by the calculation, you can see the system shall have a certification range of less than 5 microgram per cubic meters to cover both US standard and European standard. So 5 microgram per cubic meter is a very low range, and Gasmet is the only system on the market who certified 5 microgram per cubic meters, and we are able to serve both USA and European market, especially for the new plant. In Europe, for the new plant with a capacity of more than 300 megawatt, only Gasmet can serve the purpose. For the others, like from other competitors or other brand, their certified range is only 10 microgram per cubic meters. They cannot fulfill the requirements. And also, lower certified range means highest sensitivity, and the result is more accurate. Otherwise, we cannot get the certified range as low as 5 microgram. Besides the mercury, in Europe, they also set another regulations for the ammonia continuous monitoring, especially when the plant is installed SCR or SNCR, and also TOC, continuous monitoring for the waste incineration market. So that means the regulation is getting strict in Europe. I believe in Asia, the regulation will be more strict than the existing one in very near futures. So this is the upcoming regulation in Europe for the mercury control. At the moment, large combustion plant like coal burning and the waste incineration plant already have a well control for the mercury. Well regulations, they have to fully comply by 2021 and 2023. In the next step would be goes to the cement industry. They already reviewed the draft since April 2018. So we foresee next year they will come up a new regulation for the cement industry in Europe. So in Asia, especially for those countries who follow European standard, they likely to set a mercury control as well for these three industries. So now I'm going to talk about our Gasmet mercury system. Before we design our mercury system, we face a lot of challenge and the criteria for setting up the mercury system. In the world, the legislation is talking about total mercury monitoring, not individual mercury. Total mercury, that means the summation of elemental mercury and the mercury compound. However, any kind of mercury analyzer, they only sensitive to the mercury in their elemental format, not their oxidized mercury. So that means there is a conversion step to convert all the mercury to the elemental mercury before analyze. Because of this conversion step, mercury CEMS only has extractive type, no in situ mercury system in the market right now. And the mercury level is in microgram per cubic meter range, is at very low level. And also we have to consider about the interference by the SO2, moisture, oxygens, and CO2. They are moisture, O2, and CO2 is in percentage level. They will absorb the mercury and then lower the readings. As for the other challenge is mercury, especially mercury chloride. They likely to stay on the cold surface. So when we design the system, we have to use special material in the sample preparations or for the sample transportations. And also the temperature, we have to elevate to a very high temperatures and keep at 130 degrees. Otherwise, the mercury chloride will be stuck on the cold surface. So that means you can imagine that for the mercury system, it must be hot extractive type, no cold in situ type. And also we have to consider about the accurate calibration gas for both elemental mercury and the mercury chloride or oxidized mercury. There is no bottle standard available in the market in reasonable price yet, or you can use external calibrators, but the price is quite high. There is calibrators from Hofkel. You can use it for the daily calibrations. And of course, when we design our Gasmet mercury system, we consider everything. We take everything into account, and then manufacture our Gasmet system now. So this slide show you all the available technology and the design in the market. So the heat probe depth filtrations must be exist in any kind of mercury system. And also whether it is dilution or not, it depends on the sensitivity of the technology they use. As for the mercury conversions, we have wet chemical, thermal conversion, or thermocatalytic conversions. And also the next step is going to whether the mercury will be accumulated before analyzed. So they may use gold trap or reference gases. The last is talking about the analyzer. The analytical technique could be done by the absorption spectroscopy or atomic fluorescence or atomic emission spectroscopy or DOS that is developed from the optics. So in our Gasmet mercury design, it is very straightforward and put everything into simple. We use a dilution technique so we can avoid the quenching effect, and also we use a thermal converter to convert all the mercury compound and then straight to the analyzer with using atomic fluorescence. Atomic fluorescence is the best technology available in the market, which provide highest sensitivity for the mercury detections. And our system is already certified for these three market: combustion power plant, waste incinerator plant, and the cement industry. But actually, for the cement industry, we already passed the criteria. Now we are waiting for the TUV certificate. As for our Gasmet system pass, this is the whole system outlook. We use the cold vapor atomic fluorescence technologies, which provide the sensitivity more than 10 times when compared to the atomic absorptions. And the detection limit, we achieve 0.02 microgram per cubic meters for the total mercury readings. And also our system is going to measure the total mercury, not individual compound. The next, we use integrate high temperature thermal converter to convert all the mercury compound to elemental bases before detections. We don't have to use any chemical or catalyst for this kind of conversions. So the total mercury readings coming out from our analyzer is the elemental mercury plus the mercury chloride, which is converted by the converter. Besides the analyzer, we also have our self-calibrator for the daily zero and span check for the elemental mercury and the mercury chloride, which is certified by TUV. And our calibrator is certified for Core 3 tests as well. So this is the only one in the market certified for Core 3. In our certificate performance test, we achieved excellent availability of 99% and 3 months maintenance interval for the elemental mercury. 99%, that means the downtime of the analyzer for routine maintenance. So you see, over years, only 1% of the time is used for the daily maintenance or for the routine maintenance. We don't have to use the gas bottle for our system as well. So this is what we achieved: MCert, TUV-cert, and also compiled to this 2 yen standard. The certified range achieved 0 to 5 microgram plus other range for different applications. And this is our major component in our mercury system. We have dilution probe, heat sample line, air-cooled cabinet, mercury analyzer, and also the test gas generators. We have 2 versions of the mercury system. One version is for the calibrator without the mercury chloride span check. One version consists of mercury chloride span check according to this standard. And this is our system design. From here you can see the sample gases will be drawn in from the sample probe and all the way to the follow the blue line to the analyzer, and then output the readings. Here we use the dilution by the nitrogen gases. The green line, the dilution gases will go through the sample line and then dilute in the sample probe. So the actual mercury sample we take from the stack is very small quantities because the gases will be diluted, and because of this it will not cause any harmful effect to our human being after analyzed. And the dilution probe, we have a blowback mechanism to clean the dust, to purge the dust away from our sample probe. This dilution probe can minimize the loss of the mercury fluorescence signal, because mercury signal may be interact with oxygen, CO2, and moisture. Once we dilute the sample, these 3 components, the concentration of these 3 components will be diluted as well. So we can minimize the effect from these 3 components. And this is our cabinet design. This cabinet is IP54. We have our air cooler on top. However, our system still need to be placed in an air conditioning room. We have mercury analyzer here, the gas generators, and also the nitrogen generator and the other pressure regulators. It is a totally standalone design because we have everything integrated as a complete system. In the plant, you only have to supply the instrument air to kick off the pressure regulator pressure control. Then our system can be measured automatically throughout the whole years. So when we go to each individual modules, this is our analyzer. This analyzer already certified again the lowest range in the world, 5 microgram per cubic meters. And the detection limit is 0.02 microgram per cubic meters, which is low enough for any kind of applications. We use atomic fluorescence technologies, and the integrate and the converter is heating up to 700 degrees Celsius, which converts all the mercury compound to elemental form. So you can see from here the gases once goes into the converter is integrated with the analyzer, the sample cell. The converted mercury compound will be detected after conversions. So we can prevent the recombination of the mercury after conversions and also prevent the signal loss from the detectors. In our system design, we use a specific wavelength of the UV light, which is 253.7 nanometers. This wavelength is only sensitive to the mercury atoms, but not SO2. Therefore, we can minimize the effect of the SO2. Also, we don't have to use any gold trap. So the sample gases will be straight passing through the converter then to the analyzer. Every minute, we can output the readings to our customer. And this is the dilution probe. The dilution probe will be heating up to 180 degrees. And here we have a two-stage blowback system to clean the filters. And also for the span track, the test gases will go through the sample probe and then to the analyzer to the system. It just simulates the actual sample path measurements. The sample dilution is about 50 times by nitrogen gases, so we can remove the crunching effect caused by moisture, CO2, and the oxygens, as they are in volume percentage level. All the system past contacting with the sample gases would be called Teflon. The tipping would either be Teflon materials or cold stainless steel. So we are able to reduce the absorptions of mercury compounds on the sample path surface, and also we're able to reduce the salt and paste formation on the tube because the sample tube, this one, is heating up to 180 degrees Celsius. So all the temperature will be monitored by our system. In case there's any error, for example, temperature drop, the signal will be sent to the customer's DCS or reflect to our software display. So this is the only filter we use in our Mercury system. We can set the blowback features, set the timing and the interval. In case your application has a very high dust loading, then we can set it more frequent. In our sample probe, we have two-stage blowback mechanism. First, we can purge the dirty side of the filters. Then we can purge the clean side of the filter. So after the blowback, we can make sure the filter is clean from the dirt. And the filter material is glass-coated filter with 2 micrometer pore size. So we are quite confident to use our analyzer in any kind of application with dust loading of less than 2 grams per cubic meters. And this is our sample probe. The length of the probe is only 1.22 meters. However, during our certifications, we use this probe tube for the stack diameter up to 8 meters. So that means you don't have to extend the probe tube. You just keep using our standard offer for the stack diameter up to 8 meters without any problem. And the fuel gas temperatures has a limitation of 400 degrees Celsius. Cannot be more than these temperatures. Otherwise, the coating of the probe tube will be damaged, and most likely we will lose the mercury signal. And this is our sample line. As I mentioned before.
Sorry.
Yes.
Can you back to the probe? What kind of the code of the PTFE? Oh no, sorry. What kind of the code of the tube inside the stack?
It should be a glass coating.
Sorry?
The glass coating.
Glass on this. Okay.
Yes. Because the material is stainless steel. For our system, we use a glass coat stainless steel for our system design. As for the sample line, we use the PFA or Teflon tipping, and the temperature is elevated to 180 degrees Celsius. So from this picture, you can see inside the sample line, we have two heat tubes. One is for the sample path, one is for the calibration gases. Besides these two heat tubes, we also bundle the other gas tube for ball bag, ejector, or the signal wire. Everything will be bundled in the sample line. So the construction of the sample line is very complicated, and therefore we have a length limitations to 30 meters. Cannot be longer than 30 meters at the moment. And this is the power supply. It consumes a lot of power, about 200 watt per meter. So this is our test gas calibrators. The test calibrator, we use a metallic liquid for the elemental mercury calibrations. As for the mercury chloride, we will vaporize the mercury chloride solutions for this purpose. And again, our mercury chloride test module is certified for Core 3 purpose in our TUV certificate. And also the zero gases is filter instrument air, which already spot the mercury gas molecule. Our gas calibrator can offer automatic zero and span check and adjustment according to the defined interval. And also the calibration concentration could be up to 50 microgram per cubic meters. Again, since the sample gases from the process or either from the calibrator will be diluted by 50 times, so when the gas after measure and then released to the environment, it will not cause any harmful effect to the environment or even to our human being working inside the room or working around the shelter. And we use the span to probe features. All the excess mercury from the calibrator will be flowed back to the stack. It will not be drawn into the analyzer. And this is our sample pump and the filtration unit. And also we have our own N2 generators who supply 99% purity of nitrogen for dilution purpose. As for the instrument air, it is very important. It supplies the gases for ball bag and then flushing the whole instrument, and also for the nitrogen generators. And that's why the consumption of instrument air is pretty high. It's about 60 liters per minute, and we have to maintain the pressure at about 6 to 10 bar. If the site cannot provide cannot fulfill this requirement, the mercury system cannot be kicked up, cannot be started up. Any questions?
No.
Okay. So this is our embedded PC in our analyzers. We use a CVAF software we call MAUI software, Mercury Analyzer User Interface. It's also developed by Gasmet. We use a back-off modules with 4 analog output to output the signal. And also we have some relay contact as an alarm signal to our customers. In our software, it is very user-friendly and quite simple. We output the latest measurement, start or stop measurements. Once we click the start button, then the system will be automatically operated. And here there is a train wheel to plot the concentration chain during the real-time monitoring. And also there's some alarm button. In case there's a red alarm, you can click and check the details. Otherwise, in green, then it means there's no problem for our system. And also there's some manual control, especially for the surfacing. Of course, there's some setting for the analyzer and for the gas calibrator. And also in case any problem, we can click this one, support. Then the supporting package will be generated it's just a kind of file. It will be backed up and then sent to our Gasmet for the check. And also there's some software versions. So here there's some analyzer setting and a calibrator setting. For the analyzer setting, you only have to set the bowback interval to it. You have to check on the side to adjust the bowback interval. As for the calibrator setting, you only have to define the daily calibrations for the elemental mercury, and also define the concentrations for the daily span check and also for the daily zero check. As for the span calibration, it also defined when you integrate with mercury chloride modules. So everything is in automatically operate. As for the signal output, we only have 4 analog output. One analog output is reserved for the zero result. One signal output is reserved for the mercury chloride span check. And this is the result in test format. The result will be saved in here. We will record the time and the other hardware conditions. So when we cross check with the hardware conditions, we can know whether your data is good or bad. And we don't have a hard disk inside the embedded PC. Instead, we have a flash drive for file saving. The flash drive should be able to store the data more than 1 year, as we can use maybe 16 gigabyte flash drive and then store the data.
Can we send the cell temperature out for the signal to the analog, or only the result?
No, only the result.
We cannot send any data out, right?
Yes, cannot, because in case any data has a problem here, it will be reflected as a system alarm or service alarm. So you can send the alarm to the DCS, then you know the system has some problem.
You have a relay contact, right?
Yes.
Okay.
Yeah, the relay contact is for this alarm.
Only for.
So if you click the button, it will show you what is the problem. Maybe the cell temperature is dropped, or the light intensity is dropped. Is it okay?
Yeah.
Okay, so now I would like to talk about the technology we use. We use atomic fluorescence. So just pretty simple. We have a mercury lamp as a UV light source. The UV light source will direct to the sample cell. So you can imagine when the sample cell is filled up with the mercury atoms. The mercury atoms will be excited to higher level. Then from this picture, the mercury atoms will be excited to higher level. Within a very short period of time, it's talking about nanosecond, the mercury atoms will be dropped back to the lower level. At the moment, they will release fluorescent signal. Our system will capture this fluorescent signal and then to calculate the concentration of the mercury in your sample cell. So you may have a question: is it all the mercury atoms are detectable? And the second question is there any straight light detected from the UV light source by our detector? So the first questions, as you may remember, we are using the converter to convert all the sample. Once the sample is converted, the sample will be directed to the sample cell for the detection immediately. There is no gap. It is totally embedded to each other. So all the signal would not be lost. The second, at the end of the sample cell, we have a light trap. The light trap would not allow any light to reflect back into the sample cell and then captured by our detectors. So that is why we guarantee the signal is truly from the mercury atoms, not from the straight light And also we are able to measure all the mercury compound once enter into our sample cell.
The right tab, can you back again? The right tab in the end of the tube or in the detector in here?
The light trap, yes.
But the sort is opposite, right?
Sorry, can you say again?
The light source is opposite of the light tap.
Yes, correct. The light source is from here because the light only goes straight. It will be off from the light trap. It will not bouncing back to the sample cell.
Okay.
And also there's one important design. You see the detector is located at right angle to the light source.
Mm-hmm.
So the light cannot turn around to the detector.
I see. Okay.
So the quenching effect is quite popular in atomic fluorescence technologies, but we are able to minimize the effect with using dilution technique. So you can imagine there is a ground state. Once the mercury atoms absorb the UV light, it should be in excited state. If at this moment it bombarding with moisture, oxygen, or CO2, the energy will be still off. So at the end, no fluorescent light will become so. This is the quenching effect, and what we don't want to have. And that's why we have to dilute the sample by 50 times, dilute the concentration of moisture, oxygen, and CO2 by 50 times, and therefore we can minimize the quenching effects. As for the other gases in the stack, they are in ppm level. They would not do any quenching effect to the mercury atoms. And that's why dilution the sample is in purpose to minimize the quenching effects from the atomic fluorescence technologies. So as a summary, our system is certified for lowest range in the world, so our system can meet both USA and EU new emission limit value standard. And we don't have to use any sample preparations, and the measurement is continuously. Every minute we can output the data. And also we achieve 99% availability and achieve 3 months maintenance interval for the mercury, or 4 weeks for the CMM auto core. And because we achieve so no calibration range, so our system is future proof for the market. Because in the futures, the regulation will be decline the emission limit, but not increase the emission limit.
It's here. Oh, sorry. You can go next.
So this is our maintenance schedules. It is not much. We only have to refill the mercury coil liquid for our auto core and replace the mercury light source in every 6 months. As for the other filter unit, you have to replace or exchange in every years, and the vacuum pump every years. As for the filter, it's quite long-lasting. You only have to consider to replace in every 5 years. So as for the quality assurance, there's some difference between Europe and USA standards. As far as I know, Thailand is follow USA standard. You don't need to require any certificate for the system. However, you have to do a lot of testing after you finish the installations, like rata test, and then follow the US EPA PS12A 7-day drift tests. Some kind of test you have to consider. But in European, EMSA or TUV certificate already replaced this testing. In European standard, if you follow the core 2, you have after installation we need to have a third party to do a commissioning check. Most likely the commissioning check just fit the spent gases, check the linearity of the system performance. That's it, which is totally different from the one in USA. they have a lot of calibration drift tests. Normally it's over 7 days. But if they follow European standard, everything will be more easier. And also, in US standard, at least traceable test gases or generator is required for checking the mercury system. And also, normally mercury chloride is generated from the gas calibrator. There is no gas bottle available for the mercury chloride. And the radar test is in yearly basis in USA standard. So in European standard, we care about the core 3, the zero expand check measurements to ensure the proper operation of the system. That is what our end user concern, because for the core 2, that is belongs to the contractor responsibility, but core 3 belongs to the operator responsibility. In our system, we can carry out the daily zero expand check by our calibrators. So the operator don't have to put too much effort, just click the button and then finish every setting. Then our system can output the result for you, and then you can submit to the government for reporting. You don't have to waste so much time because our analyzer, our calibrator, already certified for core 3 purpose. So there is another regulation you may consider to follow. I'm not sure whether water tests have a full regulation for the mercury control yet. If no, then you can refer to this EN 14884. They describe the same system for the mercury. And also there is another standard reference method for mercury, also for core 2. So normally that is for the third party as a cost check according to this EN 13211 method. So there are some benefits for the use of AutoQual. The AutoQual that we provide automatic core 3 tests with using our calibrators. So the ownership is much lower, the cost of ownership much lower, and time saving, the result is very fast. So every maybe 1 hour you can output the result. You don't have to use external calibrator or hire a third party to do the core 3 tests. So there's an estimate for the different core 3 method. We compare the CAPAS and the OPAS with using different core 3 validation method, and there's an assumption for the lifetime of the analyzer of 10 years, and the validation times is every 3 months. They have to do core 3 tests. So you can measure for the first years with using Gasmet AutoQual. The cost may be a little bit higher when compared to the validation service. Validation service means you hire a third party to provide the service to the end user. HOVOCAL is the external calibrator you use. So it involves the purchase price and the consumable or operating cost. So over 1 year, our cost is much lower when compared with the external calibrators, but and also lower for the third-party test. 6,000 euro is for 4 times validation service for the plant. So over 10 years, our cost may be 34,000 euro, but the validation service already double than our cost. If you use external calibrator, it may be more than triple of our Gasmet cost. Further, they involve a lot of manpower and the electric and the annual service for the calibrators.
You try to compare with the CMM with AutoCal function and the CMM without AutoCal function, but it needs the HOVOCAL?
No, I'm going to compare 3 methods to fulfill the core 3 validation tools. Our AutoQual, our calibrator already have these functions, and if you don't have this function, then probably you have to use external calibrator for the core 3 purpose, or you can hire third party to do this validation service for the core 3 purpose.
So you mean if we include the auto core 3, the auto Mercury line calibration is need only the 15,000 euro for the first year, right? For the first ride only.
You mean for the first year?
I mean with if compare with our AutoCal, it should be the second line, right? The second line of the whole AutoCal.
Yes. Yeah. So when we base on the 10-year lifetime of the analyzer, our total cost for 10 years only 34,000 euro. But if you are using external calibrator, it's more than 100,000 euro. Or you can hire the third party for the validation service. It's double the cost of Gasmet. Is it okay for this?
10 years. I really don't understand what is the CAPEX, the capital expenditure. What is it?
Capital expenditure is the investment.
Investment.
That means, investment. For example, the purchase. You have to purchase the equipment.
One time.
You have to purchase the spare parts for maintenance.
Spare part.
Yeah.
Okay.
As for the operating OPEX, is the liquid. The Mercury core liquid. You have to refill the liquid. Yeah. So external HOFOCAL, you have to purchase. For example, the external calibrator, you have to purchase, and also you have to spend money on the spare parts. And the OPEX is the manpower, the liquid, and also the annual service, maybe from the third party. As for the validation service, 6,000 is fixed for 1 year, because you just pay the money to third party, then the third party will arrange everything. So every time it's about 2,000 or 1,500 something. So every year the sum up is 6,000 euro. So over 10 years it costs 60,000 euro.
Okay. So can you back to the core 3 again? The core 3 is no need the Europe standard is exactly no need the bottom of the gas, right?
Yes, correct.
Okay, got it.
Yeah. If your system do not have this core 3 certified calibrator, then you have to use bottle gas, or you use HOFOCAL calibrator. HOFOCAL should be certified calibrator for this purpose.
Okay.
Okay, so for the applications, so of course Gasmet's Mercury system is well designed for the coal-fired power industry, waste incineration, and also cement plant. Some of our customer is using for research purpose for the ambient mercury level. However, remember there's some restriction for the use of our Gasmet system. The dust loading must be lower than or less than 2 grams per meter cube, and the gas temperature must be lower than 400 degrees Celsius. So there's some case study in European coal-fired power plant. We capture the data for 1 day, and each day we do the zero and span calibrations. The calibration concentration was set to 5 micrograms per cubic meters. So you see the trend. In European, they keep the concentration in less than 10 micrograms per cubic meters, and this is for the zero span check. It took about 20 minutes for each span check. As for the Mercury span, Mercury chloride check, it may take about 60 minutes. However, Mercury chloride span check can be done in every month, not every day, if you follow the European standard. We can see in European coal-fired power plant, nowadays the emission level is less than 10 microgram per cubic meter. But actually, before that, the emission level may be quite high,
right.
and over the local regulations. That's why our customer, they install the Mercury system and have a quick check. After that, they have to do a lot of maintenance for their abatement process or the back filters. Otherwise, they would not comply the local regulations. So here, at the moment, we have more than 50 end user in the world, most mainly from the Europe. You can see from our list, a lot of customers from Poland, because in Poland they have a lot of huge coal-fired power plant, and we have signed agreement with the Poland company. They have to purchase every year for 20 units, something like that.